Okay, now we've got a parallelogram. Now it tells you that AB is 10 and BC is 6. It also tells you that DAB is obtuse. So try and make sure you've drawn it properly. I think this works. ABCD, and then angle DAB is this angle here, and that's obtuse, greater than 90 degrees. AB is 10 and BC is 6. So it looks something like that. And remember, that angle there is going to be the same as that angle there, and that angle there is the same as that angle there. Now, we've got to work out the size of DAB, so the size of this obtuse angle at A. And we also know that the area is 40. Right now, the area of a parallelogram is actually, if I draw the perpendicular there, and let's call it H, that's the perpendicular height. Now the area is going to be the base 10 times the perpendicular height, and we know that that's got to be equal to 40. Therefore, we know that the perpendicular height's got to be equal to 4, so H equals 4. So we've now got a little right angle triangle, which I'll draw out again here, looking like that. That's a right angle, that's C, that's B, that's 6, that's 4. Now what we're trying to find is this angle DAB, but that's going to be the same as the angle DCB. And if we work out this angle on the triangle and then add on 90 degrees, that should give us the angle that we need. Okay, because angle DAB is equal to angle DCB. I mean, I could have drawn my perpendicular line here, coming up from A. It was just a bit more convenient because of the way I've drawn it, to have it coming down from C. But of course it doesn't really matter, because the opposite angles are the same and opposite sides are the same on a parallelogram. So if we look at this, if we call that angle theta, then using simple right angle trigonometry, we've got cos theta equals 4 over 6. So theta is the inverse cos of 4 over 6, or in other words 2/3. And if you do the inverse cos of 2/3 on your calculator, it will tell you 48.19 degrees. And what we can do then is we can say angle DAB, angle DAB equals 90 degrees plus 48.19 degrees, and that comes to 138.19 degrees, and I've done that to 2 decimal places, which is what they want. Okay, now the next part is asking us to work out the length of the diagonal. So I'll draw it on the diagram here. So the diagonal BD is this straight line here, okay? And if I draw it out again here, so whoops, I guess it looks, whoops, yeah, I haven't drawn it great, but I think it looks something like, something like that. And we know that, yeah, my diagram's not very good, because in fact, you know, that one's 6, that one there is 6, that one there is 10, and we know that that angle, that's BD, and we know that that angle is 138.19 degrees. And what we can do, we can just use the cosine rule in order to find what BD is. Okay, so cosine rule will tell us that BD squared equals 6 squared plus 10 squared minus 2 times 6 times 10 times the cos of 138.19. And if you work that out on the calculator, it comes to something like 225.443 and so on. Square root it and you should find that BD equals 15.0 centimetres to 1 decimal place. Okay, now strictly speaking, although it's 0.0 and you might be tempted just to write down 15 centimetres, you risk, I suppose, losing a mark because they want it to 1 decimal place, and so we should put in 0.0.